So let's start the talk. Hey, thanks for the introduction. You already mentioned that I'm doing container and process migration for quite some time. I think I'm now doing process migration at least for 10 years, and the main thing my talk is about is CRIU to do process and container migration. And in CRIU, I'm involved for at least, I would say, since 2012. And I was really hoping to be in Moscow because, as far as I know, CRIU was invented in Moscow. So it would have been really great to be at the place where CRIU was invented to talk about CRIU and how it enables you to migrate processes in container. And I'm focusing on container migration. I would say maybe 2015 is that I looked closer into container migration than just migrating processes. A lot of what I'm talking about today has been written down in a blog post. This is still, I would say, probably RHEL 8.1, so it's a bit older than what we have now. So in the blog post, things are a bit more complicated and like I will show them today. So if you use the latest version of CRIU and Podman, what is my focus today, it will be easier to live migrate a container than in this blog post. So my agenda for today is I first want to present a few use cases, include a few demos in the use cases, how to use container checkpointing and restoring and how it can lead to container migration. Then I want to talk about details, especially how CRIU enables you to migrate a process. Then a few more demos, how to migrate containers. And then a few words about the future, what I have been planning to do with CRIU and container migration. And an important thing when I talk about container live migration, container migration is a definition because it's not always clear what I mean with it, or people have different ideas what it could mean. So for me, container live migration is more or less the same as virtual machine migration. So you take your container, you take your running container and transfer it to another system while it is running, or at least while it's not losing its state. So you could also say it's stateful migration, what we are doing here. And this is, from a very, very high level view, this is pretty easy. You just serialize the container on your source system and transfer it to the destination system and restore it there, and it keeps on running at the point where you checkpointed it on the source system of your migration. So as already mentioned, everything I'm talking about today is based on CRIU. CRIU is checkpoint restore in user space, and there are multiple integrations of CRIU in different container engines. I will try to list a few of them, but my focus when doing demos will be the CRIU integration into Podman and how you can migrate and checkpoint containers using Podman. So about use cases, how to use the technology to migrate container. One possible use case might be you want to reboot your system because there is some important kernel update or something like this, and you do not want to lose the state of the container. So maybe you have a database which takes a long time to initialize to get all the caches hot, or you have a large application which needs to load a lot of libraries. So it takes some time to load and get back into the state. So you can use container migration, the technology behind container migration, to save the state of the container, do a quick reboot, and then be back with your running container. So a short diagram how this could look like. So you have your, so in my picture, this is basically the memory of your system. So you have your host system running with its memory, and you have the container running with its memory, and you now want to reboot your system, and you do not want to lose the state of your container. So what you do is you do a checkpoint of the container. You kind of take the container out of the running system. You save all the state of the container on the file system, and then you reboot your system. So your system is now gone. You still have the state of the container stopped on your disk. And when you reboot the system, the container will run with the same state, although the host system will be rebooted and has different memory. Now it's green and not blue anymore, but the container will be running just as it did before. And I have a demo here for this to show how this could be done. So my demo is running on a RHEL 8.2 system, and I'm using Podman and CRIU directly from the distribution without any changes here. And I have an example container which is stateful, and it's based on Java, so it's a Wildfly container, Java application server, and it's the most simple application you can think of, which is stateful. It's an application which returns your number, and then it decreases the number, and the next time you read from the container, the number is one higher, and it's again increased for the next run. So it's a really simple application, but it's stateful. So let's start it. I say podman, and then I say run, and then -d for detached in the background, and then I have prepared a container at key.io, and it's a Wildfly container, and it has a simple hello world application. So let's start the container. The Java application takes a few seconds to start up, so something like 10 seconds before we can talk to the container. And so let's try to talk to the container. So what I'm going to do now is I'm just doing an HTTP request to the container, and what I have here is a long, complicated command. But a command basically does, it asks Podman to get the IP address from the container and put it onto my command line, and then I'm combining this with a port where the application is running and the name. It's called Hello World. So if I do this now, I should get back a 0. If I do it again, I get a 1. So it's a stateful application, and it's really simple. So now I updated my kernel, and now I want to reboot my system, but I do not want to lose the state. So I want to have the container return a 3 next time I talk to it, and not a 0, so that I don't have to start from the beginning again. So what I do now is I say podman container checkpoint, and then I want to checkpoint the last container Podman knows about, so I say -l. And now Podman will write the container checkpoint to the disk. And if I look now at my container listing, I see there are no more containers running. Now I do a quick reboot. Let's hope this is fast. I'm just gonna ping so this is a virtual machine running on my laptop. So I'm just pinging it to see when it's up again. And it should be pretty fast. So there it is already. So now I'm gonna reconnect to my virtual machine, and let's see, no container running. Let's try to connect to the container. This should fail because the container is not running and has not been restored from the checkpoint yet. So you see it fails because podman inspect fails, and then no IP address is returned. So what we're going to do now is we will restore the container. So I say podman container restore, and also -l for latest. So Podman will now read the container back using CRIU from disk and restoring the process into its state. And now I can connect again to the container, and it should now, I forgot, probably it should return a 3 or 4. It should definitely not return a 0, a 3, and a 4. So the container was checkpointed. I did a reboot. I was able to restart the container from my checkpoint. I didn't lose my state, so I was able to reboot without losing any state and have a new kernel running without any possible security holes. So back to my presentation. So this was the one use case. The other use case where you can use the technology behind checkpoint restore or migration is quick startup. So you have a container running again on your host. Like before, you have one container running there. It's all initialized. Everything is loaded. It's ready and to answer queries. But you now want to run multiple containers from the same point in time the existing container is running. So you do not want to wait for reinitialization of libraries and things like that. So the steps to make multiple copies of an existing container would basically be you do a checkpoint of the container, you write it to disk. Again, I'll take it out of the memory in my picture here, and then I restore multiple copies of the container, of the same container on my existing host. So let's go to the demo to show this. So I still have my container running from my first demo. So I see Podman PS here, the container is running. Let's talk to the container once more. I get back a 5. So what we gonna do now is we will checkpoint a container again, but we will keep the original container running, and we will write the checkpoint to an external file, which we can then use to create multiple copies of the same container. So let's do Podman container checkpoint, and then I say leave running. I hope this is called leave running and not keep running. So it's called leave running, and then I say again -L for latest, and then I say export to write the checkpoint to a file. I'll just call the file tmp and then checkpoint.tar, and so now the container is being checked. Oh, this is an interesting error message here. This is actually runc is complaining that if you checkpoint a container, it should not keep on running. So it is actually a bug in runc, which does the container starter, which controls the container from Podman, and it's just an error message, but it's already fixed upstream, but a fix is not yet in RHEL 8.2, so that's why we see the message here. So it looks bad, but it's unfortunately here, but it has no meaning right now. So let's see, the container is still running. We can talk to the container, we will get a 6. Okay, so now let's try to create a copy from that container we just checkpointed. Now I say Podman container restore, and then now I say not latest, now I say import, and now I give the path to my checkpoint archive. And now I have to give it another name, because what Podman would now try to do is it would now try to restore the container with the same name as it already exists. We can try this should be no problem. And now it will say error creating container storage, that ID is already in use, because it tries to recreate the container with the same name and the same ID. So what we'll do here is we tell Podman, give the container a new name, and we call it hello1. So this takes now a few seconds, I guess, to restore the container from the checkpoint. Yeah, there it is. And now we should have 2 containers running, and one is called hello1. This was just a container I restored. So now let's see, if I try to talk to this container, I say Podman inspect hello1. Now I should get also back a 6, because I checkpointed the container when it was returning 5. So now it should get back a 6 and a 7 and an 8 and a 9. So now the second container is returning values. And if I go back to my original container, it should now again be at, I think at 7. Yeah, 7, 8, 9. I can also create more copies of the container. Let's create 2 more containers here. Hello2, and the other one will probably call Hello3. And now they should all also start at 6 when I talk to them. So I have now 4 containers running, which are almost the same, but have different states. So this one has a 6, and I guess the same will be seen here when talking to Hello3. So yeah. So now I was able to create from one running containers multiple copies using the technology behind container migration, using checkpoint restore as done by CRIU here. So let's go back to my slides. So this was the use case for quick startup of an already initialized container. And so the last demo would be container live migration. I will do this demo at the end when I've talked about all the other things about CRIU and so. But what happens during live migration, using my pictures from before, again, I have a container running on the source system of my migration. I take a copy of the container, write it to disk. Then I will transfer the container to the destination system, and I can create on the destination system multiple copies of the container. And this way I have container migration. So this is about the use cases. Now some details about CRIU, how it enables you to checkpoint and restore processes and checkpoint and restore containers at the same time. So CRIU stands for Checkpoint Restore in User Space. And the first step is if you want to migrate a process or a container, which is just a tree of multiple processes in the end. The first step is, of course, checkpointing. And CRIU does this using ptrace. CRIU pauses the process using ptrace, so the process is no longer running. And during that time, CRIU collects all the information about the process necessary for checkpointing and restoring and writes those informations to disk. And this mainly happens using the proc-pit interface to get information about the running process. This is also the reason why CRIU is called Checkpoint Restore in User Space, because it's using existing user space interfaces to get the information about the process out of the system. So it's running in user space and using existing kernel interfaces to get information about the running process. During its lifetime, CRIU has added additional interfaces to the Linux kernel. Those interfaces are not only useful for checkpoint restore, they are also used by other things on Linux. So it's everything CRIU uses, or not everything, but a lot of things CRIU uses from the kernel are not checkpoint restore only. So once CRIU has all the information from proc-pit, CRIU goes to the next phase, maybe. It uses a Parasite Code. The Parasite Code is probably my most favorite part of CRIU, and it's also the craziest part of CRIU. If you once you understand how it works, it's really amazing that it works. And what happens with the Parasite Code, it's injected into the process. So CRIU stops the process, injects the Parasite Code into the process, and then the process continues to run with the Parasite Code in the process. And this Parasite Code is basically a daemon waiting for commands from the main CRIU process. So the main CRIU process talks to the Parasite Code and says, I need this information from you. give it to me and write it out to disk. So one of the reasons when CRIU was first developed is that getting the memory from within the address space of the process out to disk fast was not really possible. So the Parasite Code enables CRIU to write all the memory pages from the process onto disk really fast. And everything the Parasite Code does, it does from within the address space of the process. So everything the process can see, the Parasite Code can see. So once all the information the Parasite Code can retrieve has been written to disk, the Parasite Code is removed after usage. CRIU calls this curing the process, so the parasite is gone, and the process basically never knows that it was under the control of the Parasite Code and CRIU. So I try to make a small diagram here. So this is the process address space and the code in the process to be checkpointed. And so what CRIU does now, it removes a part of the code, saves it to restore it later. Then CRIU injects the Parasite Code into the process. This is now the daemon part, which is running, where CRIU can talk to. And once CRIU has finished using the Parasite Code, it replaces the Parasite Code again with the original code, and the process can continue to run. And at this point, all checkpointing is finished, all relevant information has been written to disk. And as seen in my previous demos, when I do the reboot, the target process is killed, checkpointing is finished, or the target process can continue to run. This was in my second demo where I started multiple copies of the container, and so the original container was still running, and this is basically what we have seen. This is the possibility to let a container run, the process run. So you can decide if you want to kill the process or let it run. So an interesting thing during development of container live migration was the part about SELinux, and I talked about this at last year's Linux Security Summit. And this required quite a few changes to CRIU and the stack and to Podman to make it correctly work with SELinux. Because the problem is basically if you restore the container, you want to have it to have the same SELinux attributes it had before, but the container is running inside of a container SELinux context, which is limited in what it can do, and if you restore a process, you need much more things to do than SELinux allows you. So there's it's a bit complicated to get it right. So CRIU actually had some Linux LSM support since 2015. When this was developed, the main focus was on AppArmor for the LXD integration. And what basically happens here is during checkpointing, CRIU reads out procpit attribute current to get a label of the process, and during restore, it writes it back. So it's in the end, it's a pretty simple operation, but the SELinux support was not there yet. There was an existing SELinux support, but it was basically saying, you're running under SELinux. I don't know how to handle it. I'll give up. So there was some effort necessary to get it running with SELinux, and the problem basically is that if we think about the Parasite Code, so the Parasite Code is injected in the process, and now suddenly something is talking from within the container context to the outside of the container. So SELinux is not happy for that. So we had to change a couple of things in CRIU. We had to correctly label the sockets for the Parasite daemon. We changed the SELinux labels of CRIU during restore, so we have to allow dynamic transitions of SELinux labels, so we needed additional policies here, and setting context, SELinux context of threads is also not possible if it's different than the main process. So we had to change something in CRIU here to do the context switch of threads to the right point. We needed a policy to write to NSLastPit to select a PID for our processes. We had to fix a few labels for log files, and we found file descriptor leaks. So this was some effort to get CRIU running with SELinux. In the end, now it all works out. All the demos I'm showing are with full SELinux confinement, and the restored container is also has also SELinux running just as the checkpoint, just as it had before checkpointing. So now we had checkpointing the container. The process was the first step, then the SELinux thing in between, and now the second last step to get to container migration is restoring, and what CRIU basically does here is it reads all the checkpoint images which have been written to disk and tries to recreate all the processes from the checkpoint images. One thing about CRIU is it only recreates processes with the same PID the process has had before checkpointing. And one of the main reasons is CRIU always operates on a process tree. So if you give it the PID of a process, it will checkpoint this process and all child processes. And if you change PIDs, all the child-parent relationships will probably not be working anymore once you do the restore. The problem with requiring the same PID during restore than you had during checkpoint is that you can see PID collisions. If the PID already exists, then CRIU will just abort. But as we are talking about containers here, you usually run in a PID namespace, so PID collisions is not something which will be a problem if you run in your own PID namespace. There was also a talk about CRIU and the PID dance at last year's Linux Plumbers conference. So what we call the PID dance is we want to recreate a process with the same PID it was before restore. So we have to tell the kernel we want a certain PID for our next process. So what CRIU used to do is the PID dance. We open this proc NSLastPit to write pit -1, and then we close NSLastPit, and then we really try to be quick to do a clone, and then we do a get pit to verify that it's actually the pit we requested. The problem here is that this is multiple system calls, so it's probably a bit slower, and it's racy, because between writing to NSLastPit and doing the clone, the kernel could have created another process, so it will not work, and so the new process will have another pit, and we have to abort the restore. So to avoid this PID dance, there was actually something to create a process with a certain PID already in 2010. It was called eClone, but it was not merged in the Linux kernel at that time. And so we started last year again to get something in the Linux kernel which enables us to tell the kernel we want to create a process with a certain PID. And 2019 introduced Clone 3, and Clone 3 was from the beginning designed to be extensible so that you can add additional features to this new system call once it already existed. So what we did is we extended Clone 3 to support the set TID parameter. So we can now use clone3, one single system call, to create a new process and tell the kernel which PID we want. So it basically looks something like this. So you just tell the kernel we want to create a process with a PID 2020, and then we do the syscall. And if it worked, we get a process with that PID. And if it didn't work, we get some kind of error back. So I said CRIU creates the whole process tree again. And once the whole process tree has been recreated as it was before, CRIU now changes all these processes into the processes it wants to restore. And one nice thing to describe this is, from my point of view, our file descriptors. So during checkpointing, CRIU records the file descriptor points to, the file descriptor ID, and the position of the file descriptor in that file. So we know everything about its file descriptor. And during restore, we reopen the file, the same file with the same file descriptor ID, and we position it at the right position. And once we give control from CRIU back to the process, and the process will continue to run, the file descriptor will point to the right location as it was before. And that's basically what happens with all other resources CRIU can handle. All the memory pages are mapped back into the right location. All the security settings are loaded, and security settings we do as late as possible, so that the security modules do not interfere with the restore process. And once everything has been done, CRIU just jumps back into the restored processes, and the process will continue to run. So this was my short introduction to CRIU. So now let's go to the actual container live migration. Container live migration or container migration is available in multiple container runtimes, container engines, and the first to mention here is OpenVZ. That's the product which invented CRIU to offer migration of the containers to their users. So that's where CRIU comes from. And another container engine runtime which supports live migration is Borg. This is Google's container engine, and I think 2.5 years ago there was a talk from Google at Linux Plumbers Conference where they introduced their usage of CRIU, how they actually live migrate containers in production from one system to another. So if one node is overloaded, the container will be migrated to another node. So then there is an integration of CRIU in LXD, so you can use LXD to migrate one container from one system to another. And then there's integration in Docker. The integration in Docker is, as far as I currently know, not actively being developed right now. So it's old, but as far as I know, at least from the CRIU bug tracker, people are also using it to migrate containers. And then there's the integration of CRIU into Podman. That's what I have been working on for the last 2.5 years maybe. And just a few keywords about Podman. Podman tries to be container runtime. The CLI interface is pretty compatible to Docker. So if you know Docker commands, you usually also would know Podman commands. The big difference for Podman is it's daemonless. So there's no daemon running on your system. You just start Podman, it exec and forks a container, or forks and execs a container, and it just runs without a daemon behind it. And one interesting thing about Podman is also it's rootless, so you do not have to be root to run the container. Interestingly, checkpoint restore does not work yet for rootless, but I think it might work maybe in the future. So about Podman checkpoint restore, the first discussion about checkpoint restore in Podman was around, I would say, beginning of May. I talked to people how they feel about it, and then the first code was available around May 2018, and in October 2018, the checkpoint restore code was merged into Podman and made available. So this required runc and CRIU changes and Podman changes. And this initial implementation supported basically only the checkpoint container, reboot system, and restore container use case. You were not able to move your checkpoint from one machine to another. This was still missing, so it was only checkpoint restore support. But then in June 2019, the live migration support was merged into Podman, and so since 2019, you can do the things you see in my demos. And this again required changes to all the levels, to runc, CRIU, SELinux, Podman, to make this correctly work. And the interesting thing for the checkpoint archive, it includes file system changes. So if your container changes something on its file system, these changes are also exported to the container checkpoint archive. And if you then restore the container on another system, Podman will try to pull the container from a registry, then apply the file system changes, and then restore the container. So now to my checkpoint restore demo. On the slides, I just written down all the commands I would do, but I will do the demo live again here on my system here. So let's clear the screen. I just need to here. Okay, so now let's see. I still have my containers running. Okay. So I guess I just use one of those. I don't need to start a new container. So again, I will say Podman container checkpoint. Basically the same thing I did before. I say leave running, and I say latest. Let's see which container it checkpoints. And then I say export, and I export it to a file again, same file as before, will be just overwritten. So now Podman will checkpoint my container. I get the same error message as before. Now I have the container here, or the checkpoint of my container, all in this file. Let's see how big it is. It's 74 megabytes. The 74 megabytes, I guess that's all memory pages of the Java application server, which is part of this container. So to migrate this container, I will now use just SEP to transfer my checkpoint from this virtual machine to another virtual machine. Let's see. Now I transferred it to the other virtual machine. Now I will connect to the other machine. And now let's see, is there a container running already here? No, there's no container running. So let's say Podman container, no, restore, not checkpoint, restore. And then I just say import, and I tell it the file. It was temp cp. And let's restore the container. And now I have no idea what number I should get, maybe 6 or 7. Let's see if I do now a curl, again, Podman inspect latest to get the IP address. Now I just run the command and I get 10, 11. So I've migrated a container, keeping its state from one host to another. And that's already everything of my demo here. Let's go back to my slides. My slides now, the next few slides are just the output you would see if you don't see my demos. And so about the future, often I get a question, what about Kubernetes? So I'm actually trying to work on getting container migration into Kubernetes. A few years ago, I thought this will be really hard because it feels like container migration is a bit like it doesn't fit the philosophy of containers, because containers are stateless, so you do not really need to migrate them. So I was always a bit afraid to touch Kubernetes because not because of the technical challenges, but more about will the community accept something like this at all? But now that I've seen that Google actually uses container migration in production, they use it with Borg, not with Kubernetes, but Kubernetes was also at some point, or maybe still is, from Google. So maybe this will make the discussions a bit easier to get container migration into Kubernetes. The thing, so I recently actually tried it to implement this, and it failed pretty early because with Kubernetes you usually have a pod and there are multiple containers running in the pod, and if I try to checkpoint one of the containers out of the pod, then CRIU fails with that it cannot checkpoint a single process out of a PID namespace. I think that was it. I opened a pull request against CRIU to support checkpointing single process out of a PID namespace. So this was actually merged this week into CRIU. So now I can continue looking, working on Kubernetes and working or really minimal support to checkpoint a running container out of a running pod in Kubernetes. This is one of the things I'll try to do next. And then another thing which we have been looking into recently is so non-root checkpoint restore. So currently you need to be root to checkpoint and restore a process or a container. And we have been getting questions at CRIU that people are interested in checkpointing and restoring containers, or at least processes as non-root. And our answer was usually it works almost. There's a little change necessary in the kernel, and but the questions were coming now more often. So we actually submitted a patch into the kernel to get non-root checkpointing working, and this actually might get merged into the kernel. The discussions, at least I feel the discussions are at a point where most people agree that it's mergeable. It needs a few more changes and a few more iterations, but it feels like it should be doable to get non-root checkpoint working in the future. So with this, I'm already at the end of my talk. A summary here about container live migration and CRIU. So CRIU can checkpoint and restore containers. It's integrated in different container engines and runtimes which support taking a checkpoint and using the checkpoint later. It's used in production at different sites and people. And you can, as use case, I presented rebooting into a new kernel without losing container state, starting multiple copies of an already initialized container, and what the title of the talk basically was, migrate running containers. This is all possible with CRIU and with its integration in the different container runtimes. I have one more slide here with lots of links, things I mentioned during my talk. And with that, I'm already at the end of my talk. So thanks so far for the possibility here.
Thank you so much. That was interesting. And we have a question on the chat, and Dmitry asks, well, does this technology work for cloud functions? For instance, does it support, say, migration or instantiation for lambdas running a complicated application? So can we say serialize an application and deserialize it in, say, AWS Lambda to get the startup faster?
Lambda is something, you have a Python interface where you can load Python code and you can start, and it starts up really fast and you can just put some Python code. It's that Lambda? I'm sorry, I don't know that.
I think question about AWS Lambda functions as a service.
Okay, so I guess this does not work because if the code, which is a function as a service, is not a process on its own, then CRIU cannot checkpoint it. So we cannot take code out of a running interpreter and put it into another function as a service. So this will not work. So this would need to be done on the level of the process. What we only can do is we can only checkpoint the whole process. You point us to a PID, we checkpoint it. That's all what we can do. We cannot take out specific information about the process. This must be done by the application itself.
Yeah, as I know, it doesn't support it in Lambda. Yeah. I have another question.
There might be a follow-up to the question, like, can we treat CRIU as a way to serialize our binary? Well, it might be a bit bigger, but it might be fastest to start up. So can we probably, I don't know, serialize, start up the application, make a CRIU snapshot, share it to some, I don't know, file storage, and at the time we need to start the application, we can download the binary, deserialize it with CRIU, and launch it. Does it work, or are there some limitations? So what do you think?
So yes, this works. There and when I talked about non-root CRIU use cases, one of the use cases was about non-root was to integrate CRIU into Java. So you have a JVM, and the JVM can use the CRIU library interface to dump itself to disk in its initialized state, and later it can use the information to restart from that state much faster than reloading all the libraries. So people are actually working on getting this into JVM. That I know of that, and I think that's what this question was about. So it's doable, but you have to somehow work or change your application or each application has to include CRIU on its own to do that, yes.
And what about network connections? Is it possible to do seamless connection migration? So a follow-up question from Dmitry.
Yeah. So this works. So we so UDP is not a problem because it's stateless. So we can restore the sockets in the same state as they were during checkpointing. So if your clients can handle changing IP addresses, it will just work. For TCP, it also works, and actually Podman also supports this. So if you have a container, you connect to it, and try to checkpoint it, the checkpointing will fail. And if you look at a CRIU log file, it will say you have to use the option --TCP established. And this is working with Podman. So if you do a checkpoint again, say --TCP established, it will checkpoint the information about open TCP sockets. The only thing you have to do during restore, the IP address needs to be there. You cannot restore a TCP connection if the IP address is missing. So if you migrate your IP address from one system to another, then it works. And I've done this before, so this actually works without a problem, I would say. Yeah. So network connection can be handled. What people often ask is GPUs. That does not work because CRIU cannot get a state of the GPU out of the GPU, or at least we don't know it. So if people would be willing to write something which gets the state of the GPU out of it, which we can later inject back into the GPU, then we could also checkpoint applications using GPUs.
It's an interesting problem because, I do a lot of machine learning, and it would be interesting to do checkpoint with GPU state and then do live migration.
Yeah. We get a few questions of this, but as soon as the hardware device is open, it does not work. So what you could do is, but I don't know if it still makes sense. You make sure your application closes the GPU, then you do the checkpoint, and then you reopen the GPU after checkpoint or after restore.
But in this case, I need to do some changes in my application to support it.
Yes, right. Yeah.
And as I understood, with the normal CRIU, I don't need to do any changes. It will be supported as is.
Yeah, right. So this is one of the things which CRIU tried to do. There were different checkpoint restore implementations before for Linux, but they all had some requirements that you have to preload libraries or things like that, or link to a certain library, and CRIU has no requirements on the process. It can, and that's the reason why we can basically checkpoint any container as long as it doesn't use a GPU or something like that. And so that's one of the important things about CRIU. I used to call it's completely transparent to the user. You just run it and it should just work.
Very interesting. And do I need some special version of the kernel or some special distro? Will it work with any distro? Linux?
Yeah, so a few years ago we still mentioned this, but I think it was it's really a long time ago that kernels were too old. So if you have it even works with RHEL 7 and RHEL 8. So RHEL 8 has 418, 419 kernels. So if you have a recent distribution, it usually works, and then you just take the latest version of CRIU, which usually comes with the distribution, and it should work. That depends on the distribution if they update it fast enough. But most of the time today, now like 8 years that CRIU now exists, things are all available in the different distributions without any problems, I would say.
And as I understood correctly, it's possible to migrate containers between different versions of the kernel. Will be there can be there some issues or incompatibilities between versions of the kernel? How can I be sure that a new kernel will work with my process and container?
So I would say the biggest problem is the VDSO. So the part where the kernel system calls are not going to the kernel but to the VDSO. And if the VDSO changes between kernels, then you could come to a situation where it doesn't work. This basically depends where your code currently is. If the code is outside of the VDSO when we do the checkpoint, then CRIU will patch the VDSO to point to the new VDSO and everything will work. But if you are currently in the VDSO while the checkpoint is happening and the VDSO on the destination system is different, then it can fail. So this is a situation which CRIU cannot handle. So and you cannot really detect it before. You need to, I don't know if you see if the VDSO is different between kernels, but if you I guess if you stay on a distribution which has the same kernel main version, then it's pretty unlikely, I would say, that a VDSO changes. But that's not a part I'm an expert about. So,
So as I understand, I can be pretty sure that everything will be okay if I migrate, for example, on the same distro from Red Hat Linux to Red Hat Linux with the same minor version. Yeah. But if I will migrate from, let's say, Amazon Linux to Red Hat Linux with completely different kernel versions, there can be issues.
It could. I actually never tried migration between different distributions. So yes, but you could get problems if you have different distributions on your system. I would say it could happen. Yes.
Yeah, but it's not the popular, I think, case because who will do live migration between the different distros? But yes, it's interesting
usually
in theory.
Yeah.
I wonder if there might be a case for patching the application in between the migration. So what if I want to patch my application? I serialize it. I don't know, somehow modify the snapshot while it is not running, and then I restore it with getting the bugs fixed. Is that something you are aware of?
So if you know what you're doing, I'm pretty sure it will work. But I guess it can be challenging to find all the right things you have to change. But I would say it's if you know what you're doing, I guess it's doable. But I haven't heard of it as far as I know. I don't know.
Well, the snapshot of the application might take a noticeable amount of space. Are there ways to, I don't know, reduce it so we get the snapshot smaller?
Okay, so there are there's one thing which used to exist and which has been recently re-implemented is something we call an image server. It's basically CRIU doesn't write the files to disk; it just streams it to an image server, and the image server automatically transfers the data to the destination system. And I'm not sure, but depending on the configuration, it probably never hits your disk. But then you need to have the memory to store the data about a checkpoint. But this doesn't actually reduce the checkpoint size. That was what you asked. And another thing which you can do is CRIU supports pre-copy and post-copy migration. So pre-copy migration is a thing where you write a checkpoint, the process keeps on running, you transfer the checkpoint to the destination system, and then you do a second or third or multiple checkpoints, which then only have the delta, only the changes with only the pages which have changed since the last checkpoint are then transferred to the destination system. So the actual checkpoint is not really slower, but you can decrease the migration downtime by using pre-copy. And there's also post-copy where you restart the process on the destination system, and then missing memory pages are retrieved on demand while the process is running from the source system of the migration. This has been integrated on the run C level. We can do that, but I think like STI also supports pre-copy migration, but none of the other tools, as far as I know, support pre- and post-copy migration already. You can use it on run C, but not on the higher levels yet.
Oh, that's cool. Can you please clarify how the process mapping works? For instance, if I had multiple copies of my program at the source machine, they might get shared the memory, so I don't really use physical memory twice or multiple times, but kernel reuses it, right? How does the process behave after it gets recreated from CRIU?
I actually don't know this part. Sorry. So that needs to answer some other CRIU expert. I've never thought about it yet, but so I guess no, I have to guess too much to answer it. So because I guess the kernel still maps the pages of the process into the memory. So. And we only migrate the memory pages and not the process binary itself, how it's mapped into the memory. It's too much guessing for me here. Sorry.
Okay. And do you probably know how, I don't know, shared libraries work?
Again, what?
Shared libraries. So if I have, say, libc mapped to the memory of the process, does it still gets mapped as a shared library, or it is mapped as a brand new map process page?
I don't know. I would say it's still mapped as a shared library, but I cannot give you a definite answer here.
I have a different question, not about shared libraries. I use Docker a lot, and yes, I know Docker and this technology, and your demos are impressive. I want to have this functionality in my setup, but I'm really concerned about Podman. Is it possible to have similar functionality with vanilla Docker, or I should migrate to Podman also when I want to use CRIU? And is it easy to migrate to Podman?
So I wrote a Podman implementation of Checkpoint Restore. So you should definitely migrate to Podman. And
Okay.
as I would say, as long as you do not use it's complicated. So I think the main difference, or a few weeks, the main problem, as far as I know, I'm not deep into Podman, but I know that Docker Compose was not available with Podman, but now Podman has been switched to a new API, which, as far as I understand it, should be compatible to the Docker REST API. So Docker Compose could work with Podman. That about this, and so Podman should be a drop-in replacement for Docker if you want to use it. The Docker checkpoint implementation, if somebody would work on this, I'm pretty sure it could do the same things I did for Podman. So it's all there it's all there in runc, it's all there in CRIU. You probably have to write some code to get it working with Docker, but I actually never tried the Docker checkpoint restore implementation before. So
Okay. Maybe you can try to write implementation for Docker also, because this functionality is really good. I really want to have it in Docker also, but I'll try Podman. I never did it, but you convinced me to try.
Oh, cool.
And I want to see how shared libraries also work. It's interesting technology. So I don't have any other questions.
Okay, cool. Then, you mentioned that there are, say, pre-migrate and post-migrate steps. Is there, say, application API available, so my application can integrate with CRIU by removing unnecessary stuff before migration?
Can you ask the question again? I'm not sure I understood it correctly.
Okay, for instance, my application might have some data in memory which does not really it is not of high priority. It can be recreated, but it still might take time and space in memory and transfer it. So is application level API which I can, implement or consume, so my CRIU will call it before migration, so application will release the memory, release the resources, and make the process, faster or more efficient.
Okay, so you want a way for CRIU to tell the application to release memory before doing the checkpointing.
Oh, yeah.
I'm not aware of anything like this. So the Java integration I talked about. So when I've been talking with them, they often said if you do checkpoint restore in Java yourself, you can do much smaller checkpoints, because Java would know which pages it needs and which pages it doesn't need. But the thing is, then you have to recreate everything which CRIU already does. And CRIU is basically dumb about the memory. It just dumps everything. It just doesn't care about. So I guess we don't have anything there. So you would just need to, invent a signal, and when your application receives the signal, it just frees all the memory it currently doesn't need. But we don't have any API defined for this. But but besides signals, it's probably difficult to find something which everybody can agree to use. And so this is probably something you have to do on your own in your application, as far as I know. Maybe it's something which you could integrate in container runtimes more easily, that you say a container runtime will send this signal to the application, and the application can handle it or not. Maybe this is something which is more likely to work at some point. Something like that.
Okay, thank you. Can you please clarify what is their top challenge for you for now?
This is the top challenge is, I would say, is getting the functionality somehow into Kubernetes. So I'm still one level below Kubernetes, working on working for Red Hat. I selected CRIO as the CRI runtime. I tried to integrate checkpoint restore there. It failed. I wrote the patches for CRIU. Now I have to go back to CRIO and try to integrate this. And the main challenge will be to convince somebody to make this available at a Kubernetes level, I would say. And the other thing I mentioned, the non-root use case would be also interesting. There are a lot of HPC high-performance computer users who would be interested in non-root. Podman rootless could use non-root CRIU, and there are also other users who are using CRIU as non-root with different workarounds to be able to migrate big processes from one machine to another. Those two things are currently, I would say, important to get done and make it available for our users.
Oh, thank you. Am I right? The technology is not really about migrating processes cross architectures. For instance, if I migrate my x86 to ARM, does it work?
No, we had, there were two research projects which talked to us, and what they basically, if I understood it correctly, they created special binaries. They called it, Big Elf or some Fat Elf files where you have code for both architectures in your binary, if I understood it correctly. So you need a special compiler, you need a special CRIU version to use it. And people have showed that it works from x86 to ARM that works, but it has not been merged in CRIU or intercompilers. So this is all research only. But if you want to do it, I think you can find it somewhere on probably on GitHub also, and it's doable. But the use case is not so big, I guess.
Okay, thank you. And can you please clarify how CRIU relates to hardware? So do you use some technologies from the hardware, or are you just using the high level and you do not use the hardware features as it is?
Hardware features. So I've seen code in CRIU. So there's this functionality, I think, on Intel CPUs to switch between processes. It's called something xsave to save registers. And I think CRIU uses that if it's available. So, but other hardware things, I'm not aware how CRIU uses hardware features, or maybe I did not correctly understand the question.
Yeah, that was the question. Like, are there special instructions that help CRIU, or are there, say, peculiarities which you have to overcome somehow?
So yeah, so the CPUs have to support the same. So if you dump the process on a system which uses the xsave features, you have to have it also on the destination system. If not, CRIU will fail. CRIU has a possibility to check the CPU features on your source and destination system and make sure this will actually work. But most of the time, the CPUs are similar enough that you do not have those problems.
Yeah, thank you.
Gentlemen, that's it. Probably we are running out of time and we have 1 minute left. Can you please tell the final words to all our audience before we go in further into this Zoom session?
Yeah, so CRIU is production ready. Please try it out. If it doesn't work, come to CRIU upstream on GitHub. Open tickets. We usually can help you if you try to migrate something and it fails. So, but please go ahead, use it. It's really cool.
Thank you so much. That was a nice talk and nice discussion. I look forward to see you sometime later in the discussion zone in the Zoom. So in case you have any questions left, please don't hesitate to join us in an after talk session where you can ask any questions, etc., etc. And I have to say thank you so much. See you later. It was a nice talk. See you around.
Yeah, thank you for having me.
Bye.
Bye.